Welcome back. We're going to continue our discussion on chemical kinetics. As you would see, the time per video is going down. From the first video, you would see that there's a pattern. The amount of time it's taken to learn a new concept is considerably going down. And this is very, very common on almost any exams I have seen outside. It's a very common question. And it's probably one of the easiest things that anybody should be able to do. They could give you a graph like this one, or I could give you a graph like this one and ask you if there is any intermediate or transition state. Some of you might be coming into my organic chemistry class, and this is a knowledge you must have if you're going to come into that class. Not knowing even the difference between an intermediate and a transition state, and not knowing if there is one given a graph, just makes you look really weak coming into my organic chemistry class. So let's address that so you are comfortable with that idea as you come into my organic chemistry class. So here we have a graph, and you typically see your y-axis is an energy, and you may see reaction coordinate or reaction progress or progress of reaction, one of those things on the x-axis. So this is a traditional energy versus reaction coordinate graph. And if I ask you, does this reaction, this is for a particular reaction, you know, just like how each of us have our unique DNA blueprint, each reaction, sometimes reactions might have a common profile, even though the space between each of these mountains might be different. So in a way, every reaction has a unique reaction profile, and this is a profile graph. Think of it as a profile for a particular, some unknown reaction, okay? So the crests, okay? The crest indicates transition state, okay? The crest indicates transition state. So TS stands for transition state. The trough indicates intermediates. Is that all? How difficult was that? So TS stands for transition state. And I could stand for intermediate, but I literally wrote it. So this particular reaction's got two transition states and one intermediate. Now let me say something that's something my high school chemistry teacher, probably perhaps my undergraduate chemistry teacher told me is, all reactions have transition state, but not all reactions have intermediates. I don't want to go more into that. You will see that when I see you in organic chemistry. So all reactions have a transition state, not all reactions have intermediate. What I'm saying here is you will always see crests, but you won't always see troughs. So you could expect something like this. So if a reaction goes like this and comes down, if this is reactants and products, you don't have an intermediate here, okay? This is the start, this is the end. Start, end. There's only one crest, and so we have a transition state, no intermediate. Okay. There's another way the same question could be asked, which is not using graphs, but say I give you a bunch of reactions. I'm just using a generic reaction here. This translates into almost any particular reaction. So A plus B going to C. C then goes on to make D plus E. And say D then goes on to make F plus G, okay? There's two things we can get out of it, and I ask you, what are the intermediates in the above reactions? Which ones can you cancel out? That is, which one exists on both sides? If you can cancel out something that exists both on the right and the left side, then those are what your intermediates are. I can cancel out C and I can cancel out D. That means my overall reaction is anything that's left out after you cancel, you should keep the left side on the left side, right side on the right side. Okay, so A plus B going to E plus F plus G. This is the overall reaction. I'm trying to kill 3 things in one so I can keep the video time to the minimum. This is how you write overall reactions. So the intermediates are C and D are intermediates. So whichever one you can cancel out are usually the ones that are called the intermediates. See how simple this concept is? And that's all I want to say on the concept of intermediate versus transition state, and I'll see you with another video.